Hello, Algebra 1. It is lovely that you clicked into this video, and hopefully it will help remind you of our journey this year. We have covered a lot of topics, and you have been applying those topics to your math, and I'm just really glad that we got to do this together. It is time for us to start reviewing for a bit of a final quiz. That's coming up at the end of the week. So we're going to take the next few days to kind of cover all the topics that we've covered in this class and give you one last assignment on each thing. So when we first started out, we started out with solving equations. And so if you remember, these are one-step equations. I'm going to ask you to pause this video and real quick solve these. I'll be back in just a sec. All right. So when we say solve, we mean to get that letter or that variable all by itself. And so these are called one-step equations because it really just takes one step to do it. So on this one, you want to get v by itself. And remember that our equations are balanced. They have two sides. And we want to take care of what's on either side individually, and then combine those into cancellations and doing the same thing to both sides. When we're taking a look at these equations, they are completely simplified. There's no distributing, there's no combining like terms, and so it's really just a matter of subtracting 2 off of both sides to give us the answer v equals 8, and this is done. Now, number 2 is only slightly trickier because when you subtract, my board is all uncalibrated. When you subtract 16 from both sides, which is what you're going to do because then you're creating this cancellation, you've got a negative left over. But 6 minus 16 is negative 10. And you can handle this a few different ways. You can divide by negative 1 on both sides. You can multiply by negative 1 on both sides. Or you could just say, well, if negative h is negative 10, then positive h has to be positive 10, and there's your answer. When you're looking at number 3, you have multiplication, which there's no multiplication symbol anywhere. And math is confusing sometimes. But if there's no multiplication symbol, you have to assume that you're multiplying. So what 3 is saying is 4 times x equals 12. So what number times 4 gives us 12? Well, let's see. If we balance these equations, remember that there's kind of a dotted line down the middle of each one, keeping each side separate. We can see that those sides have been simplified completely. There's no parentheses, no combining of like terms. And since we're multiplying, in order to do the opposite, we're going to divide. Divide by 4 on both sides. This creates this cancellation, and you have x equals 12 divided by 4, which is 3. Last one, number 4, you are dividing. You have x divided by 2 equals 4, and so you're going to multiply by 2 on both sides. That creates this cancellation, and you have x equals 4 times 2, which is 8. All right. So like I said, this whole week is going to be about review. Today we're going to solve equations and inequalities. So update that notebook and let's get to it. You can start a new notebook page. You can add to the notes that you already have on these topics. However you want to do it is fine. On Friday, you're going to get a final quiz. Oh my gosh, you guys, we're almost there. So in this review, we're going to touch on solving one-step equations, two-step equations, multi-step equations, equations with variables on both sides, and solving inequalities. And I want you to remember that even though that looks like a lot of different stuff, those are the steps right there. Those will be the same for almost everything. The only thing that we'll add to is when we talk about solving inequalities. But basically, you look at each side of that equation separately. You either distribute or combine like terms or both. And when you get done with that, you're going to do the opposite to create clever cancellations and make sure you do the same thing to both sides. And you do those things over and over and over again until you've got that letter by itself. That's pretty much all equation solving is those steps right there. So let's start in. One-step equations are like what we did in the warm-up. And let's take these steps and make sure that we do each one. So remember, we're going to simplify both sides separately. So we have to look for opportunities to distribute or combine like terms. And in number 1, we do not have that opportunity, and so we're done with that step. The next thing is to create a clever cancellation by doing the opposite. Well, number 1 says 3 times y, and so we're going to divide by 3 to create our cancellation. The last step is to remember to do the same thing to both sides. Now we have the cancellation, and we have y equals 9 divided by 3, which is 3, and that problem is done. Number 2, when we look at simplifying, either side is completely simplified as well. And so we have n plus 7, so we're going to subtract 7 and make sure we do the same thing to both sides. There's your cancellation, n equals 10 minus 7, which is 3. Number 3 is m minus 3 equals 6. Each side separately is completely simplified. We are subtracting 3, so let's add 3 and make sure we do the same thing to both sides. Here's your cancellation, m equals 6 plus 3, or 9. Last one, we have x divided by 4. Each side is already simplified, no parentheses, no combining of like terms. And so we're going to do the opposite. If we're dividing by 4, let's multiply by 4 on both sides. That creates this cancellation, and x equals 5 times 4, or 20. And that is how you do one-step equations. Well, then we can take it to two-step equations, and those are nicely named because it takes 2 steps to solve them. And again, like in one-step equations, the simplification step is kind of already done. If we look at the opposite sides of 2x plus 9 equals 5, on the right side, there's nothing to do with the 5, and on the, on the right side, and on the left side, you can't combine the terms of 2x and 9 because they're not like terms. There's no distribution to do, and so we're going to go right to creating a cancellation. Now in this one, it's just a little bit more complicated because you might try to divide by 2 right now, and then you would find yourself having a complication. So why don't you instead start with subtracting 9? Because you know that that's going to clear that out of that side. As long as you do the same thing to both sides, you're okay. Now that 9 is gone, which is handy. You have 2x left over equals 5 minus 9, which is negative 4. Now divide by 2 on both sides. And then you have that cancellation, and x equals negative 4 divided by 2, which is negative 2, and you're done. Let's take a look at number 2. Again, both sides are completely simplified, and I would suggest that you zero in on the side that has the variable, but get rid of the term that doesn't. In other words, subtract the 1. Get rid of that first. It's the easiest thing to get rid of. Subtract 1 from both sides. You have this cancellation, then you have negative 6y equals 31 minus 1, which is 30. Now you can divide by negative 6 on both sides to get rid of the negative 6, and you have y equals negative 5. Done. And number 3. Again, completely simplified on both sides. Getting rid of that 3 is going to be a matter of adding 3. Make sure you do it to both sides. These cancel. 3h equals 9, 10, 11, 12. And then since you have 3 times h, divide by 3 to give us h equals 4. Two-step equations, y'all. You can do it. Now it starts getting a little bit crazy, and this is where the simplify step is going to start coming into play. When you have multi-step equations, there's just more to think about. You're always going to end up turning these into a 2-step and then a 1-step equation like we just did, but we're going to have to simplify first. So let's take a look at these equations. Make a slightly longer dashed line this time. Now looking at the right side, that 27 is completely done. There's nothing to do with it, so we're just going to leave it alone, and we know that on this side we will have 27. However, on the left side, we need to simplify because we have like terms. Notice that we have a 3c and another 3c. Because those terms have the exact same variable raised to the exact same power, then we can put them together. And it's like 3c's plus another 3c's is 6c's. And we've taken care of simplifying those. And then our plus 15 just comes along for the ride because there's nothing to combine that 15 with, and we have simplified both sides separately. Now that you can't simplify anymore, you can start creating clever cancellations, and now it's just a two-step problem. Let's get rid of that 15 first. That's kind of the easiest thing to do here. That cancels nicely on that side, and we have 6c equals 27 minus 15, or 12. And then since it's 6 times c, let's divide by 6. Make sure we do it to both sides to create that cancellation. And we have c equals 12 divided by 6, or 2. And there you go. All right, let's look at number 2. Now this one's slightly different because we've got some parentheses, but that's okay because we have the distributive property. And the distributive property would tell us that we can take this 3 that's right there next to those parentheses and quote unquote distribute it inside of those parentheses by multiplying. So in this first case, we have 3 times 3n, which is 9n. And then we have 3 times negative 5, which is negative 15, equals 21, because nothing to solve on that side. And all of a sudden, we've got a two-step equation. We already know that we want to get rid of that term that doesn't have the variable, so we're going to add 15 to both sides. That creates this cancellation, and we have 9n equals 21 plus 15, or 36. Oh, sorry, I just dropped. I just dropped the microphone. You guys okay? All right, so then divide both sides by 9. I'm all shook up. And we get n equals 4. 36 divided by 9 is 4. Gosh, I hope so. So that's multi-step equations, and they can get crazy, so why don't we do another one just so we see that we just keep following the same steps. So on this side, on the left side, we can't put the 5x and the 2x together yet because the first thing we have to do is get rid of the parentheses. So remember that when you do the distributive property to get rid of parentheses, you have to multiply by the number that's right next to those parentheses. So this 5x, we can't really do anything with it yet, and so I'm just going to bring it down. Now also notice that this isn't just a 2 in front of those parentheses, it's a negative 2. And so we're going to multiply negative 2 times x to get negative 2x, and negative 2 times negative 3 for positive 6 equals 30. All right, and now we've distributed, but notice how we have some like terms right here. So we're going to take care of those next. 5x's minus 2x's is 3x, plus that 6 that has nobody to combine with equals 30. 30 is completely simplified. And now that we have no distribution to do, no like terms to cancel, we can start, no like terms to combine, we can start canceling. So we're going to get rid of the 6 on both sides. And we have 3x equals 30 minus 6, which is 24. And then we're going to divide both sides by 3. And we get x equals 8. All right. So even if it does look kind of crazy, those steps are all you need. They're just going to kind of tell you how to get through stuff. You're going to distribute or combine like terms or both, like we did in this problem. Once you get done with all that, you're going to create clever cancellations by doing the opposite, and then do the same thing to both sides. Now, this still applies when we have equations with variables on both sides. It's just that it's going to look a little bit different. Remember that the first thing to do is simplify both sides separately. So let's do that on number 1. Now, when I look at 5n minus 7, I don't see anything to distribute, and I also don't see any like terms I can combine. So When I look on the other side, 9n plus 21, there's nothing to distribute, and there's no combining of like terms. Remember, that equal sign is like a wall. I can't combine 5n with 9n yet. They're not on the same side. I have to simplify separately. But once I've looked at each side separately and realized that both of these sides are already simplified as much as they can be, that's when I move on to creating clever cancellations. Now at this point, I could subtract 5n from both sides. That would be fine. I could add 7 to both sides. I could subtract 9n from both sides, and I could subtract 21 from both sides. All of those are great first steps. I'm going to subtract 9n from both sides. I just like to get rid of the variable that's on the right side. I'm going to line that up with my variable on the left. These cancel, which is exactly why I did it. Now on this side, I have 5n minus 9n, which is minus 4n. The negative 7 comes down because we haven't combined it with anything. And then we have the 21 left on the right. And now it's a two-step equation. In order to get rid of that negative 7, I'm going to add 7 to both sides. And these cancel. I have negative 4n equals 21 plus 7, which is 28. And then dividing both sides by negative 4 gives me n equals 28 divided by 4. Oops. Oh, it's 7. How did I not know that? But it's going to be a negative 7 because we have a positive divided by a negative, and so negative 7. And there you go. So even if it's got variables on both sides, you still consider both sides separately, then create clever cancellations, and then do the same thing to both sides. All right, y'all. Here's a crazy one. Let's do this. This is going to be fun. Oops. Okay. So let's simplify both sides separately. All right, so when we're looking at the left, we have 3x minus 8 times 2x plus 3. We need to distribute because we have parentheses. But we can't distribute with the 3x because it's not right next to the parentheses, and so we're just going to bring it straight down. That means that we're going to take this negative 8 and distribute it onto that 2x, and negative 8 times 2x is negative 16x. And then we're going to take that 8 and distribute it onto that 3, and we'll get negative 8 times 3. Negative 8 times 3, which is going to be negative 24. And that's going to equal, now we're going to simplify the right side. We have a negative 6 times 2x, which is negative 12x, and a negative 6 times 5, which is negative 30. All right, now let's check these sides again to see if we're completely simplified. And it looks like we've got some like terms, 3x minus 16x to combine over here. So it's like taking 3 minus 16, and that is negative 13x. And minus 24 stays by itself because there's nobody to combine it with. And on the right side, negative 12x and negative 30 cannot be combined because one has an x and one doesn't. And so we just bring it down. Now that we have simplified both sides separately, we are ready to create cancellations. So we could add 13x to both sides, add 24 to both sides, add 12x to both sides, or add 30 to both sides. And at this point, all of those would be a correct step, but I'm going to add 12x to both sides. Because I like it when the variable term cancels from the right side. It's just what I like. So we have negative 13x plus 12x, which is negative 1x, minus 24 equals negative 30. Well, then we want to get rid of that 24, so let's add 24 to both sides. These cancel. I have negative 1x equals negative 30 plus 24, which is like 30 minus 24. 30, so 24, 25, 26, 27, 28, 29, 30, which is 6, or negative 6, sorry. And then let's divide both sides by negative 1. These cancel, and we have x equals 6. And there you go. So the problems can be really complicated looking, but it's the same steps every time. Simplify until you can simplify no more. And that's always going to be either distribution or combining like terms or both. Once you get done with that, you can start creating your cancellations, making sure you do the same thing to both sides, and just do that over and over again until you get that variable by itself. And it looks complicated, but it's not a lot of steps. All right, so when we're solving inequalities, it's mostly the same, but there's one big difference. When you multiply or divide both sides of an inequality by a negative number, you must flip the inequality. You got to. So we have the steps here: simplify both sides separately, distribute or combine like terms or both, create clever cancellations by doing the opposite, and then I just added this one step right here for when we're dealing with inequalities. If you multiply or divide both sides of an inequality by a negative number, flip that symbol. You got to do it. And then do the same thing to both sides. So when we're dealing with equations, we don't have to worry about flipping the symbol. But when you're dealing with inequalities, you do. So let's see what it looks like. Solving inequalities is just like solving equalities. There is kind of a wall between the two sides. This is a one-step inequality. I'm going to be subtracting 5 from both sides. I don't have to flip the symbol because I didn't multiply or divide. I created this cancellation here. I have k is less than or equal to negative 3 minus 5, which is negative 8. Now, the other piece of solving inequalities is graphing. And so I'm going to throw this on a graph, which is essentially a number line. I'm going to put that negative 8 here in the middle. A bigger number than negative 8 is negative 7. And a smaller number is negative 9. So I'm going to put those two sides. Now, this k is either less than or equal to negative 8. Remember how we had the open dots and the closed dots? Open looked like this or that, and closed looked like these or those. And so this is a closed dot situation. And then k is less than negative 8, and so we're going to color this direction, and there's your graphing. Number 2, p plus 7 is greater than negative 2. Let's see. I'm going to subtract 7 from both sides. I have not multiplied or divided, so no need to switch the symbol. I have p is greater than 7, 8, 9, negative 9. Here's our number line. Negative 9 here, negative 10 there, negative 8 there, and I've got an open symbol at an open dot at negative 9, and p is greater than, and so we color that direction. Alrighty, inequalities. Just 1 second. Okay, we just got 2 more to go, 3 more examples to go. So it says to simplify both sides separately. Fine, there's nothing to do in number 1 here. So we're going to create a clever cancellation by doing the opposite. Now notice that I'm going to be multiplying by 7. Since I'm dividing by 7, I'm going to multiply by 7. That creates this cancellation right here, and I have n on this side, and I have negative 1 times 7, or negative 7 on this side, and now I have to decide whether or not I have to flip the symbol. Because if you multiply or divide both sides of an inequality by a negative number, you flip the symbol. Now I did multiply, but I multiplied by a positive number, and so I do not need to flip that symbol. It's going to stay exactly the same. And now I can make my graph. Negative 7 here, negative 8, negative 8 there, negative 6 there. And let's see, I need a closed dot because I got that little line underneath, and n is greater than. And so there you go. That's what that looks like. Now let's look at number 2. I've got negative 15 is greater than or equal to negative 3w. Now I want to get rid of that negative 3, so I'm going to divide by negative 3 on both sides. Well, let's see. On this side, negative 15 divided by negative 3 is positive 5. And on this side, I've created a cancellation, so there's just w, and now I need to decide whether or not I have to flip the symbol. But did you notice that I divided by a negative? And since I did, I have to turn it around. I divided by a negative, and so I had to flip the symbol. Now, when graphing this, I'm going to put my 5 on there. Smaller than 5, bigger than 5. I need a closed dot at 5 because there's that little line underneath, or the or equal to part. This says 5 is less than or equal to w, which means that w is bigger than 5. And so I'm going to color this way. Got to be careful with that coloring, because sometimes some people automatically just color in the direction that the inequality is pointing, and sometimes that's not right. So you got to think about what's going on there. All right, this is the last one. We're going to throw it all together. Let's divide this up. We have lots to do here. Looks like we're going to distribute, because there's lots to do here. We have to simplify first. And since we have parentheses, we're going to distribute. Now we're going to distribute by the number that's right next to those parentheses. So I'm going to have 5 times 3, or 15. Sorry about that. And then I'm going to have 5 times negative x, or negative 5x. And then I'm going to have 2 times 3, or positive 6. And then 2 times negative x, or negative 2x, is less than 14. Sorry about all that feedback. I don't know what's going on. All right, and so now I've distributed, and now I need to think about combining like terms, because you see how I have a 15 and a 6. Those can be thrown together. 15 plus 6 is 21. I also have a negative 5x minus another 2x, or negative 7x. And that's going to be less than 14. And now I think I've finally simplified everything. So now I'm going to be creating clever cancellations. I think I'm going to get rid of that 21 first. These cancel. I have negative 7x is less than, oops, that's too far over, but it's all right. 14 minus 21 is negative 7. And then I've got negative 7 times x is less than negative 7. Well, I'm going to have to divide by a negative on both sides. That creates this cancellation, and I have x. This side, negative 7 divided by negative 7 is 1. But since I divided by a negative, I have to flip the symbol. Don't forget, that's really important. Throw it on a number line. I don't need a number line anywhere near that big, but here we go. And it's going to be an open dot at 1, and x is bigger than 1, and so that's what that looks like. All right, you guys, bottom line, when you're solving equations and inequalities, it always comes down to the same series of steps over and over and over again. Just when you're dealing with inequalities, remember that if you multiply or divide by a negative, you're going to have to flip that symbol. That's the Solving Equations and Inequalities review. There's some practice on quizzes. I hope you have a wonderful day, and I'll see you next time. Bye.